Hi everyone, welcome back to my series on building an end-to-end machine learning pipeline. In the previous 3 lessons, we trained a model using PyTorch Lightning, converted the trained model to ONX format, and packaged it into a Docker image for running inference with fast API. Now it's time to store our work on GitHub. A common challenge when pushing large files to GitHub is their size, because GitHub only allow up to 100 megabyte to be pushed directly on GitHub. To overcome this, we can use the GitHub the Git LFS that is used to handle large files. However, it is not ideal because it tends to be very slow, and it comes with limited storage on GitHub. To actually address this limitation, I would use DVC, which is the short form for data version control. So here you can go to the DVC website and read through the information about DVC. I will talk about this later. So first, let's push our work to GitHub. So we will start by creating a new repository. So first we go to our GitHub page under repository, click new. We will give it a name. So this is already available, so I will choose emotion recognition pipeline. Okay, it's available. We will keep it public. It is optional to add a README file. I often add it. So we will create a new repository. So now the repository is created. Under code, we will copy the address of the repository. Next, we will open VS Code, clone this repository. So we will paste the address that we copied just now, hit enter, choose the location on the local computer that we want to save the repository. I will choose desktop. Okay, let's open it. Here you can see there is nothing inside except for README file. Next, we are going to add any file or folder that we want to push to GitHub. Let me add all the lessons 1, 2, 3, 4 here. Let's just copy and paste 4 lessons. So now we are going to link between our local computer and the GitHub repo. To do this, I will open a new terminal. Let me check. Yeah, so here we have all the copy files. So I will create a git init. So what it does is it will link the local directory to the GitHub repository. In order to upload files to the repository, we typically run 3 commands: git add to add any file that we want to upload to the GitHub repository, git commit in order to commit the file that we want to add, and finally git push. So I will go through each of these. Note that large model or data files often pose a problem. If we try to push them directly, we will fail. If you try to do the 3 combination just now directly, the model files that are in these folders will not be able to push directly because their size exceed the allowed size of GitHub, which is usually 100 megabyte. In order to address this, I will create a file called gitignore. So I will create a .gitignore file to tell Git to ignore these files, which will be handled later. Let me check what I have here. So I will ignore all the model files in lesson 1. So You can see when I write this in Gitignore, this model folder is automatically gray out, which means they are ignored. I will do the same for other lessons. So 2, 3, and 4. So I will ignore all the model files. But they have different names, right? Lesson 2 is inference organics. There's no such thing as lesson 2 setup. Lesson 3 is fast API and Docker. And this is the name of lesson 4. So this lesson we'll talk about Github, DVC, and S3. All right. Not only the model file is the file that we want to ignore, we also want to ignore the data file. So this CSV file is over 200 megabytes. So if we push it directly to GitHub, we will have a problem. So this is this file, right? So now it's gray out, and in lesson 2 we also have the same file. So we should exclude this file as well. And yeah, other than that, it looks okay. Lesson 3, what is this Docker URL inference? Okay, we also have model for this file where we use inference with Docker. So this is under Docker URL inference. Yeah, let's just gray out everything. Let's just not include anything from this folder. It's not important for these lessons. And then for lesson 4, which is actually this lessons, we will not touch the models. All right, so now things look good. Make sure you save this file. I set an automatic save, so every time I type here, it will be saved automatically. Now let's check what files are ready to be pushed. So we will type in git status. So git status tells us which files are ready to be pushed. So the files that are ready to be pushed are here. Right? All these are new files that are not currently in GitHub. If everything is good, we will actually we should have a git add first. So git add dot here tells GitHub to add all the files that are currently in the local computer, and they could be, all of them could be pushed. Adding embedded. I have some warning here which I'm not sure about. So why it is warning me on this lesson 4? I have another Git repository inside my current repositories. Maybe that was the one which I created before I record. Anyway, let's just move on and see if there is any problem. So here, when I check this status, I can see all these are new files that are ready to be pushed to GitHub. So now we will commit. Just type in the commit message. This is the first commit. So after we commit, we will push it by typing git push to the main branch, git push origin main. So now, yeah, so it is done. Let's go back to the repository, refresh it, and make sure everything is pushed. So here you can see everything is pushed, but there is some issue here, which probably because I created some repo where I push lesson 4 up, and then now it's trying to tell me this might conflict with that repo, but I already deleted it, so I'm not really sure what this is about. Okay, so hopefully this is fine. Next, I will talk about DVC and Amazon S3. Right? So basically, DVC acts as a placeholder for large files like dataset or the model file. These large files are usually stored on places like Google Drive or Amazon S3. DVC works alongside Git. Right? Git is used to check metadata files like the .dvc file that you will see later. DVC manage the actual large files in the remote storage. So let's just first try to install and initialize DVC in the computer. So I already installed DVC. If you haven't done so, you need to install it via pip install DVC, and let's initiate DVC in this repository. So type DVC in it. So this means it is initialized. DVC is initialized, and when you do this, it will create a .dvc file. A .dvc file here. Actually, this supposed to be in lesson 4. So yeah, let me just this might introduce some conflict. Yeah. I should do this in lesson 4. So here .dvc already exists. If I do this, because in this lesson 4 I already have DVC inside, so if I try to redo it, it will fail. So it asks me to use Fox. Perhaps DVC init F. Okay, so now I just reinitialize the DVC in under this folder lesson 4. When you do this, it will create a .dvc file and DVC ignore. So basically they are similar to Git. DVC ignore tell DVC to ignore whatever that is we don't want to check. Basically I don't ignore anything, so there's nothing to ignore. And this .dvc file. Next, we are going to configure a remote storage on Amazon S3 to store our train model. What is Amazon S3? Let's ask Google about it. So S3, Amazon Simple Storage Service, is a service that allows users to store and retrieve data in form of objects. Basically, data in S3 is organized in buckets. Right? We will start by creating a bucket to store our train model. First, you will need to sign in Amazon S3. So let me sign in. It has been quite some time I haven't used it. I don't even remember my password. Let's hope that it is correct. Okay, not correct. Okay, it's fine now. So now we are in S3. In order to create a storage place, you will start by clicking create bucket. This will prompt you to create a new bucket. Under this bucket name, you can type anything, right? You can say model DVC. I already have one, so I'm not going to create another one. I already created a few. And let me just try it out. Why not? So create. It's already exit, so you need to choose train DVC bucket. So the name needs to be unique. Well, so here you can see this is the one that I just created. In order to save the model, I will create another folder on which I would use to save the model. So let's say train model. Yeah, so here this could be the place that we can use to save the train model. Well, before we can actually push our model to S3, we will need to configure credential for this purpose. Note that credentials are required to access any AWS service. You will start creating credential by going to the username from the top right here. Click security credential. So on this spec, you will scroll down, right, and click create access key. Yeah, and here when you click this, let me try. You need to understand. You will be given an access key, which is here. Together with secret access key, you should download the .csv file. Here I already have it, so yeah, let me just create another one. Why not? Right? And then done. So now this is the one that I just created. You will need to set these access key in your environment. In your terminal, you can type export AWS access key ID. You need to go to this file here. Let me show you how it looks. This is a CSV file. Yeah, basically you need to copy and paste all this. Right? You need to set this in your environment. I already have one, so I'm not going to do it again. But let me just try to do a new one. So access key ID equal to this key, and export AWS access key ID and secret access key. This is the secret one that you should keep it secret, equal to something. So you should have it here and type it in. let me go back to the file. Where is it? Should be here. Okay, whatever it is, let me just do it here. Alright, so now we are going to check what is in S3, our S3, by the following command: aws s3 list out anything that is in our S3 package. So here we need to type in the name of our S3 package. What is the bucket name? Okay, I'm in credential. Where's S3? Let me go back to S3. So the one that I just created is this. Let's check what is here. As you can see, there is only the train model file, right? Next, we will configure S3 as remote storage in DVC. In order to do this, you will first need to install DVC with S3 support. So you need to do pip install DVC S3. I already installed this, so I'm not going to do it again. Let's just do it again. So here just this is already installed. We will initialize DVC again. It's already initialized. So next we will obtain the S3 URL. Right. Actually, it is just the name of the one that we just created, and we could set the S3 folder train model as the remote storage location for DVC. So here I'm going to show you a way where you don't need to type out the name. You will just need to go to this under train model and copy S3 URL. So this will copy the URL of your S3. In order to set up the S3 folder as the remote storage location, you need to type DVC remote add. The flag D here means default. We give a name for the location. I call it model store, and then paste the URL of the S3 folder. So the D flag here, set the remote we are adding as the default remote storage. That means any command that follows, which include DVC push or DVC pull, will use this remote unless we specified otherwise. Model store is simply the name assigned to the remote storage. This is just a short form for this whole thing, train models. Now let's hit enter. Right, so we have set the remote storage, and now it is time to add our model to DVC and push it to S3. So let's look to models here. So here I have train models.onx. This is the file that I want to store on S3. I will first add this to DVC. In fact, when you do DVC add, it will create a file like this. So to illustrate this to you, I will delete this file first. So now under this model, I have two models. One is the usual PyTorch model. The other one is the train model.onx. Okay, so this is under model. Let me first add the ONX models to DVC. When I do this, you can see now a dot DVC file was created, and let's open up this file. This file is basically a metadata file that checks this train model.onx, and in this file we have several things. The outs here lists the output that DVC is checking. In this case, we only check the train model.onx file. And path here is the relative path to the file being checked. These two are in the same folder, so the path here is just train model.onx. For the hash here, M5 and hash here, my understanding is they are just the hash of the check file. So now, in order to push this model to S3, we just push the DVC file. Right? We'll type DVC push models .dvc. So now this will push our model, the ONX model, to S3. If we go back to Amazon S3 and refresh, you will see here this is our model push to S3. So this is store under files. All right. So now our model has been pushed to S3. It is no longer needed to keep it on our local computer, and let's delete it from our local computer. Right? So let's just delete these things. So here, instead of keeping the model file that can be very large, we are keeping this file where it is a .dvc file which contains only a few lines of characters. This is extremely small. Now let's say if we want to pull this model down from the remote storage, what do? We simply run dvc pull on this DVC file. So instead of DVC push, we will type DVC pull. Look here, and you see this model now is pulled from S3 to our local computer. Well, so this is pretty much it. Actually, okay, now. Yeah, the lucky thing is this .dvc file is not yet in GitHub. I believe so. Let me go back to the repo. So under lesson 4 here, the problem is this is in another branch, which I'm not sure. There is some branch conflicting here. Okay, so basically, in order to keep this model, now there is no need to store it anymore. Right? All we need to store is this .dvc file. So in our git ignore, we can now push this .dvc file to GitHub. As long as we have this, we are able to access to the original model. So here, let me just add anything that is new to GitHub. Check status. So here all the, okay, I still need to ignore the PyTorch model. So let's just ignore it from here. Now it's lesson 4, right? Lesson 4. Models and best checkpoint CKB. Yeah. This doesn't seem to gray out this things. The problem is I am now in lesson 4, right? So I might need to change the directory. No. Well, anyway, this original model is not needed for this lesson, so I'm going to delete it. And then okay, remove these things. Okay, so now let's say git add status, and here under models, not sure why I put git ignore here. Okay, so the problem here is I have a git repository for this lesson 4 only, so that's why I'm not sure whether this is going to resolve the conflict, right? Okay, so let's start the git add. All right, looks okay now. Add DVC. So let's check again our repo. Yeah, but usually when you do this, this will push the DVC file, but my problem here is I already created, I guess I already created this some repo for this lesson 4 where I yeah, and now it has some conflict, which I'm not sure how to resolve it. There seems nothing in this lesson 4 or things here. Maybe let me just show you my original one. This one is only for this lesson, and I plan to delete it. Perhaps the one that caused conflict is in this one. If you know how to resolve this, please let me know in the comment. So here you can see under lesson 4, when we check the models, we only need to keep the DVC file. Okay, so that is how we can create a DVC file, and by using the DVC file instead of the whole model, we have access to the original model whenever we want, right? And the way to do that is to pull the model from this DVC file, and the command here is git pull. I'm sorry, the command here is DVC pull, and call on this DVC file. Here I'm not in this lesson 4. Yeah, so when we run this, we will download the model from the storage. That is the end of this lesson. I hope you find it useful. See you next time.